Okay, last time we covered the discrete probability distribution, which is we listed all the possible outcomes represented by the discrete random variable, and then we show the probability of each outcome. Look like this. And today we continue our study of the probability distribution by checking the continuous probability distribution. Continuous probability distribution usually results from measuring something. The purpose is to identify the probability that a specified range of the values will occur for continuous random variables. For example, let's say this scale here is measuring the life of the batteries. Like, let's say this side is 0 and this side is 50 or 100 hours. And then assume we select a battery randomly out of a box of the batteries. And then we try to check out the probability that the battery we selected from the box, its life lasts between these two range, okay, from 5 hours to 10 hours. We try to find out the probability that the battery's life fall into this range, or we try to measure that the probability that the battery we got, its life will fall into the range of the 10 to 12 hours. It is not like the discrete probability distribution, which is based on the individual values. Continuous probability distributions are based on interval. Okay, the probability is represented by an area under the probability distribution. Remember, it's represented by the area. There are several families of continuous probability distributions, say the different shape of the distributions. And in this class, we are going to focus on the normal probability distribution. What is normal probability distribution? Let's check the characteristics. This is very important. Okay. The distribution is bell-shaped, like this, and symmetrical around the mean in the middle. It's a symmetrical distribution. Because the shape of the distribution is symmetrical, so the mean equals to median. They are the same value and in the middle. Values near the mean, where the curve is tallest, have a higher likelihood of occurring than the values far from the mean. Means in the middle of the distribution means the probability is higher that the value is going to fall into the range. The fourth feature, total area under the curve is always equal to 1. It's always equal to 1. Why? That means the probability of the values follow over the whole range is 100%. It's 100% probability that the value follow over the whole range. That's why, because we use the area, right, to represent the probability, so the whole area is 1. Because the distribution is symmetrical around the mean, so the area to the left of the mean equals 0.5, means the probability of the values falling into this half is 50%. Same thing, the area to the right of the mean is 0.5 as well. The left and the right ends of the normal probability distribution extend indefinitely. Next, still about the features of the normal probability distributions. Normal probability distribution their shape is completely defined by its mean and standard deviation. So the distribution's mean decide the location of the distribution. So say, okay, for the different mean number mu1 and mu2, and the distribution is located different places. And the sigma increase or decrease the spread. So as we can tell that this green color normal probability distribution has a bigger sigma, right? Means the data widely spread around the mean. And this orange one means, with a smaller standard deviation, means most of data clustered closely to the mean number. So how do we find out the probability for any given specified range of the values? Here is the formula. And don't get confused by this complicated formula because we will not use it. Okay, we have other ways. Before I introduce the other ways, and let's check, I'm gonna introduce you a standard normal distribution. Standard normal distribution is one kind of normal distribution. Why it's standard? Because this distribution has a mean is 0 and standard deviation is 1. And for this distribution, we already developed a table. Okay, that table is you can find out any probabilities corresponding the certain specified range of the values for the standard normal distribution. Our method is we are going to use standard normal distribution as a ruler, okay, as a ruler to mirror other normal probability distribution. What does that mean? Means we're gonna convert or transform any normal probability distributions with any mean or standard deviation combination. We're gonna convert or transform them into a standard normal distribution, and then we can use the table I just mentioned, right, the standard normal distribution table, to find out the probabilities. Okay, let's back to this standard normal distribution again. I just want you to know that for the standard normal distribution and the value here, okay, the continuous random values here, the x, we call that z value. We call that z value or ZScore. And using the standard normal distribution table, we call that a z table. We can find out the probabilities, associated with each x value or the range of the x value. That is, I just mentioned z value. Therefore, the method gonna be how we convert any normal distribution into a standard normal distribution. That is, we need to transform x units, okay, the x units from any normal distribution into the z units, okay, the z, the value on the standard normal distribution. And the resulting z value, we call that ZScore. The formula for that is z equal to x minus mu over standard deviation. So ZScore equal to the any value from that any normal probability distribution minus the mean, the population mean, then divided by the population standard deviation. Here are some features of the Z-scores. Z-scores are negative for the values of x that are less than the distribution mean. Z-scores are positive for the values that x are more than the distribution mean. This score at the mean of the distribution equals 0. Okay, I'm gonna show you here, which means if we convert the any x for this distribution into the standard normal distribution, and the z-score for the x which less than the mu number on this side gonna be negative, and the z-score on this side means the z-score for the x greater than mu, the mean number, are positive, and the z-score for the x equal to the mu gonna be 0. Okay, for example, to find the z-score for x equal to 180, if x is distributed normally with the mean, mu is 100 and standard deviation sigma is 50. Therefore, the z-score for x equal to 180 is 180 minus 100 over 50 equal to 1.6. So this score for this value x is 180 is 1.6. If you take a closer look at the z-score formula, you can find out that z-score is actually measuring that how many standard deviation the given value is far away from the mean number. So we can, explain it. 1.6 is this x equal to 180 is actually 1.6 standard deviation away from the mean 100. See, it says x equal to 180 is 1.6 standard deviation above the mean of the 100 because it's positive. If it's negative, it's going to be the 1.6 standard deviations below the mean of 100. Okay, let's check the graph. That can help you understand more. So for this normal probability distribution, we just successfully converted it into the standard normal distribution. So this is the distribution with the mean equal to 100, right? And the standard deviation is 50. Well, we convert that into the standard normal distribution, that is mean is 0, and the z-score for the 180 is 1.6. Now we can use the z-table, the standard normal distribution table, to find out this area. Okay, the value of this area. Remember, we use the area represent the probability, so we're gonna find out the probability that the value follow into the range. What's the range? The range of between 100 and 180. So how do we use that table? Okay, how do we use that table? In that table, the column here represents the second digit of the desired z-score. Okay, the second one. And the row shows the value of the z to the first decimal point. So the z value we just got is 1.6, right? So 1.6. You find out 1.6 from here. Okay, go all the way down to find out 1.6. And this part showing the second digit. So the second digit is 1.60. So you find out the 0.00. Then go all the way down, and this one go, horizontally. We get the cross at this point. We get the 0.9452. So this value showing the probability that the values follow into the range. Okay, you can see here that 0.9452 we got refers to this whole area. Okay. So now we found out the probability is 94.5% that the value gonna follow into this range. How do you find out the probability of this side? It's easier, right? Because we already got the area of this part, and this side we can find it by using 1 minus 0.9452. Why using 1? Remember, the whole area under the curve, okay, is 100%, is 1. So 1 minus this part, we get the area of this yellow area is 0.0548. So 5.48% the probability that a value is gonna fall into this range. Okay, we just done with if we know about the values or we have specified the range of the value, and we try to find out the probability, right? The probability of that value fall into that range. What if we know the probability, but we try to find out the range? Say, for example, suppose that mu is 100, the same question, and sigma is 50 for normal distribution. Find the x value. Means you need to find out this value, right? So that the probability of z less and equal to x, the value less than x is 0.9. So we try to find out if the probability is 90%. So let's just say the 90% of the probability that the value is going to fall into which range. That is the question. So first, let's find out the necessary Z-score. So based on the Z-table, once we know the area, the size of the area, we can find the Z-score first, and then we convert the Z-score back into the x value, right? Back to the x value. So what we need to do now is look in the body of the table for 0.9. Here is the table. So let's looking for in this table, in the middle part, right? The body of the table showing the probabilities, means showing the size of the areas. So let's find the 0.9. Okay, this one is closest to the 0.9. And once you find this, go horizontally, move to this column, we find 1.2, and then going up we get the 0.08. So this 0.08 is the second digit of the Z-score. So corresponding to this area size, that is the Z value is 1.28. Okay, 1.28. Once we find out the Z value is 1.28, we just plug it in this formula. Okay, so Z equal to the x minus mu over the sigma, then x is the mu plus Z times sigma, right? So x is 100 plus Z value is what we just got, 1.28 times the sigma. Sigma is 50, the standard deviation. So we get x is 164. So that means the probability that the values fall into the range from the minus infinity to the 164 is 90%. Or we say we want to know the range for the 90% probability. The range gonna be the minus infinity to 164. Let's check examples of the minus Z-score. Suppose that mu is 100 and sigma is 50 for normal probability distribution. So exactly the same distributions. We try to find out the probability of x greater than 72. So we try to find out the probability that a value is falling into the range that are greater than 72. Right. So how do we do that? Again, we need to find out the z-value for 72, right? So we got the z-value for 72 is 0.56. And using the z-table, as you can tell, z-table for the 0.56 is, we find out the 0.5 first, and the second digital is 0.6. So 5.06 is 0.7123, is this one, 5.123, right? So this whole area shows the 0.7123. Okay, this whole area is 0.7123. Okay, hopefully you understand more about the probability distribution, the continuous probability distribution. Now let's revisit the empirical rule. Remember, you learned that part in previous chapter. Okay, so for normal distribution, that 60%, 68% of the probability that a value is going to fall into the range of mu plus or minus 1 standard deviation. Okay, 1 standard deviation away from the mean, 68%. And a 95% probability that values fall into this range, the mean plus or minus 2 standard deviations. And 99.7% that values fall into the range of mu plus or minus 3 standard deviations. How do we deal with the other situations? For example, you know the two specific values and you try to find out the probability of that. First we need to find out z-score for each one respectively, right? The z-score for 48, z-score for 38 first. Say using the z-score formula, we find out the z-value for 38 is minus 1.4, z-value for 48 is 0.6. And then we're going to use in z-table to look up the areas, the probability for each z-score. Using the z-table, you can find out the areas of this part for the 48. Then you find out the area of this part for the 38. So you're using the bigger area minus the smaller area, you got the area of the middle. So the probability of the values falling into the range of the 38 and the 48 is 64.49%. You can also use Excel, okay, to find out the normal probabilities. So using the function of the norm dist, this function in the Excel, you just type in the equal. Remember, type in equal first. NORMDIST, DIST, then the x, the mean. The x is the given value, right? The mean number, standard deviation, then type in the cumulative. Okay. And select the true if you want the cumulative probability, or select the false if you want the probability density function. For example, this distribution mean is 45, and you try to find out the probability that is the value falling into this range, which is less than 48. So you type in the normal dist, 48, right? The given value, mean is 45, standard deviation is 5, and type in the true, so you get the cumulative, right? This whole area, the size of this area, that is the probability that the values fall into this range. This seems easier and less troublesome to use the z-table. Okay, there are a lot of stuff to learn for this chapter. Please let me know if you have any questions. Again, email is always the best way to find me.